Hey y'all, what's up? Alright, so here's the next video. So today, your main thing you had to do is going to be the recap for SOL 6.4. Pretty short questions. And then there's something else, but I don't remember what it is. Okay, alright, so let's get started. Alright, SOL 6.4 is dealing with exponents. Okay. So when we have an exponent, we look at see like this. The larger number is called the base. That's the number that we're going to multiply. The smaller number is called the exponents. That's going to tell us how many times we're going to multiply. Okay? This is not 5 times 3. That 3 is going to tell us we're going to multiply that 5 3 times. 5 times 5 times 5. And that's it. Okay? So, that's the first part. And then we're going to go ahead and look at the second part later on. Okay? All right, so here we go. Number 1, based on the pattern shown, what is the value of 3 to the 5th power? Okay, so that 3 to the 5th power, that means it's going to be 3 times 3 times 3 times 3 times 3. Okay? So they go ahead and tell us 3 to the first power is 3, 3 to the second is 9, 3 to the third is 27. Okay? So what I'm going to do, like what we talked about when we looked at exponents 4, is I'm going to start combining a few of these. Okay? So I know 3 times 3 is 9. 3 times 3 is 9 times 3. I can multiply 9 times 9 to make that 81. 81 times 3. I'm going to come over here. 81 times 3. Yes, I could have done that in my head, but I want to make sure. 1 times 3 is 3. 8 times 3 is 24. So 3 to the 5th power is 243. And my answer is D. Let me make this again very clear. That is not 3 times 5. It is not 15. Okay? All right, number 2, explain the difference between 2 to the 3rd power and 3 to the 2nd power. Well, the main way to show the difference is if I write this out, 2 to the 3rd power, that's 2 times 2 times 2. 3 to the 2nd power, that's just 3 times 3. Well, 2 times 2 is 4. 4 times 2 is 8. 3 times 3 is 9. Okay? If you want to put that in words, that's fine. Or if you want to just show exactly like I just did, that is also fine. Okay? All right. We're going to skip over number 3 for right now, because I'm going to come back to perfect squares here in a minute. Okay. All right. Number 4, what is 10 to the 7th power? Okay. So that, again, we are multiplying. We're going to multiply the 10. The 7 is going to tell us how many times we're going to multiply it. Okay. We are multiplying. We are not adding. We are not multiplying 10 times 7. We are multiplying the 10, so I know my answer is C. We are not multiplying the exponent that many times. Okay? All right, number 5. Identify all the answer choices that are equivalent to 5 to the 4th power. Again, all. Okay? First, let's go ahead and narrow that one out pretty quick. Okay? It is not 5 times 4. Again, that is 5 times 5 times 5 times 5. Okay? It is not 5 times 4. That means it is not 20. We already know we can write this out in expanded form. Okay? I can also even say that that's 125 times 5, because I can combine 5 times 5 is 25. 20 times 5 is 125. And I can even write that as 125 times 5. Okay? If I multiply 125 times 5, that will give me 625. So, and I'm not for sure how they even got there. 625 times 5 is 625. 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 625 ti 3,125. Okay. All right, number 6. What is the power of 10 to the 7th power? Okay. So again, we talked about this before. This is what's called the powers of 10. Okay. Where I'm just going to multiply it by 10 every single time. Now, like what we talked about before, is all we're going to be doing is if you look at the exponents is going to tell you how many zeros you should have behind the 1. So if you look right here, 10 to the first power is just 10, 1 0. 10 to the second power is 100, 2 zeros. 10 to the third, 3 zeros. So if we're looking at 10 to the 7th, I should have a 1 and then 1, 2, 3, 4, 5, 6, 7 zeros. Remember, after every third, we should have a comma. So I'm looking for 10 million. So it'll be C. Now I can look at the others, and I can tell it's 10 to the it's power of 10. So this one I have 3 6. So this one is going to be 10 to the 6th. 3 4, 10 to the 4th. 3 4 5, 10 to the 5th. Knowing your powers of 10 will help you out a lot next year when you get to 7th grade, especially when you're talking about the negative powers of 10 and when you get to scientific notation. Okay? But again, powers of 10, whatever the exponent is, that's how many zeros you should have. Okay? All right. Number 7. So next thing that we're going to look at, the last part, is called perfect squares. Okay? Perfect squares. I want to go over here. Perfect square, again, is I'm just going to take any number and I'm going to multiply it times itself. Okay? So like 1 times 1 will give me 1. 2 times 2, 4. And we can keep going. 3, 4, 5. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6, 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11, 121. 12 times 12, 144. These are the main perfect squares that you need to remember for our case this year. Okay? Next year, when you get to 7th grade, you're going to go all the way to 20. Okay? But then we've just got to be able to know these for right now. Okay? All right, so let's hop back to number 4. I'm sorry, number 3. So which number is a perfect square? Okay? Well, perfect squares are one of those you probably would have memorized. But again, a perfect square is we're going to take a number, so I'm just going to call that number n, and I'm going to multiply it by itself. So n times n. Okay? Well, the only one that I can multiply a number by itself would be 36. That's 6 times 6. Okay? All right, and the last one, number 7. What is the next perfect square in the sequence? So I have 4, 9, 16, 25, 36, 49, 64. Well, I know for 64, that is 8 times 8. So the next one would be 9 times 9. 9 times 9, because I know my multiplication facts, is 81. Okay? All right. So that's it for today. If you got questions, email me, message me in Classroom, hit me up on Facebook, Instagram, and we'll see you tomorrow.